Hi, I'm Amy Dansby. I'm a software engineer in commercial software engineering.
And hi, I'm Dimitris, a software engineer on the Azure PlayFab multiplayer servers team.
And welcome to What is Project Thundernetes, how Kubernetes helps games scale. I'm pretty excited. This is our first time we're publicly talking about this. We've been working on this for a few months now.
Yeah.
With some other awesome engineers. So briefly, we're going to be talking about what is a multiplayer game server and how and why they're different from traditional applications. A brief overview of PlayFab multiplayer servers and game servers on Kubernetes. And then talk about the solution that we created, which is called Thundernetes. And this allows your Linux game servers to run on Kubernetes. And then, of course, a demo showing how you can get your own game up and running using Azure Kubernetes services.
Awesome. So before we dive into specifics and Thundernetes and everything, right? You want to give us a quick overview of what a multiplayer game server is?
Yeah, so in game server hosting for multiplayer games, we use something called dedicated game servers. This allows us to simulate game worlds. Players connect to the server with their own client programs in order to see and interact with the game. The server is always the boss. Yeah. Game servers are usually session-based, short-lived, and each session is completely independent.
Except
for MMOs, which are massive multiplayer online games, and those are usually longer-lived.
Yeah.
They maintain state in memory, and they transmit that state to the client, so they have an accurate view of the world. This prevents cheating and hacking in games.
Which is bad.
Yeah, so just keep in mind that game servers are the authoritative source of events on for multiplayer games. So I think we should talk about why game server architecture is so different from traditional applications. When I play a game and I just press a button on the controller and everyone else is playing the same game, that's all that happens, right? I'm just pressing a button.
Yeah, well, no. A lot of stuff happens, right? So imagine you're playing Halo, for example, right? And you press right on the controller, right? So this information goes back to the server, and the server has to do some processing. First of all, we have to see that you don't cheat, so you don't go through walls, right? So you have to do a collision detection there. And then, there are a lot of actions happening on a game. People jumping, shooting at each other, all that kinds of stuff, right? So the server needs to process all that very, very fast, right? So maybe 20, maybe 30, maybe 60 times per second, right? So this information has to be processed very, very quickly on the game loop, and then it has to broadcast it back to the clients. And how is the way that clients connect to the server? They need an IP and port, right? So for each game server, there is a unique IP and port combination that clients use to connect.
And we can create our game server with any engine, whether it's Unreal, Unity, or our own proprietary, right? That's not specific.
Everything.
Okay. So all those things have to happen. That goes from the client to the server, but it also has to go back to the client. And then all the clients, since it's a multiplayer game, right?
Has to go very fast.
So what about the life cycle? So game server builds are sometimes massive in size, right?
So they're big. Things they contain the game, the entire assets, the map, everything. Right? So a common pattern in the game server hosting industry is to what we call pre-warm the game servers, right? So to pre-warm the game server, we have to load them, right, and to get them in a state that are ready to accept players, which we call standing by.
Standing by. Okay. Okay.
At this state, the matchmaker or the lobby service, right, when people connect there and they match, right, it can allocate a game server. When you allocate a game server, you can transform it to active, and then you get this IP and port back, send it to the players, and then players can connect.
But what makes it a little different too, allocated game servers are never deleted or scaled down, right? Because if that happens, then the players will not be happy.
They will get upset.
So game servers are okay to go down since there's no players connected though, right?
Yeah, standing by can go down,
right?
Yes, but active, no.
But what about when the game session is over?
So that's the best pattern to exactly reset the state, right? So instead of clearing the memory and resetting the state, when the players leave the server, you just exit the server, right? Exit the process, and then once you exit the process, our control plane has to get up a new process, so players in standing by, so players can connect and play.
Okay, so now we've kind of explained this game server architecture. Let's see how to host a game. And Microsoft has some expertise in this area, right?
Yeah. We're going to talk about the Azure PlayFab multiplayer server service, or we're going to call it MPS for short, right? Which is basically an orchestrator for custom game servers that allows you to host game servers worldwide.
And a lot of this was, MPS was influenced for our Thundernetes design as well, right?
Yeah, exactly. Right. So before we're going into MPS, right, let's talk a bit about Azure PlayFab, right? MPS is a part of Azure PlayFab. So Azure PlayFab is a rich set of services that you can use throughout the course of your game. Services for virtual currency, user content management, player management, leaderboards, and of course, multiplayer services like matchmaking or multiplayer server hosting. So let's share a bit about some details about MPS. MPS is a custom orchestrator for game servers. It can scale efficiently using Azure. You can go to a web portal and basically create build in all the regions we support. Right? And the good thing about it is that it supports auto-scaling by design, right, natively. So once you create a build on a region, you tell it, hey, I want an X number of standing by servers. And MPS will do everything in its power to bring up as many standing by servers as possible. We support Windows and Linux, and as I mentioned, we have a nice developer portal and an API that you can use. And yeah, see here you can see some of the great games that have been using MPS and have been running successfully on the platform for many, many years.
So what about some game studios want to manage their game using Kubernetes? What can they do? And then also, we should probably talk about what Kubernetes is.
Well, I mean, people are on this talk probably know what Kubernetes is, so we're going to be short, right? But in essence, Kubernetes is what we call an orchestrator, right? Consists of two parts: the orchestrator and the control plane and the nodes, right? So the control plane is actually the part of Kubernetes that manages the nodes, manages the workloads, the lifecycle, right? And nodes are the virtual machines where your workloads are running, right? Some cloud providers also, they have what we call managed Kubernetes, where actually the control plane is managed, like Azure Kubernetes Service, right? There, the control plane is managed for you. You don't see it at all. You only interact with it. What you do see is your virtual machines where they're running your workloads, right? Other than that, Kubernetes also has some stuff about service discovery, load balancing, resource allocation, and auto-scaling, right?
Okay, I got it. So self-contained processes are portable, reproducible, scalable, and if you want to distribute that container to be able to scale up and down quickly, Kubernetes can help make sure everything is healthy. So Kubernetes is this container management, right? Mm-hmm. Called a pod.
Yeah.
The pod sees the container, but Kubernetes only sees the pod.
Yeah, yeah.
Then we group the pods, and they're located on either a local or virtual machine, right?
Pod is actually the base entity of Kubernetes, right? You can think of it like, one or more containers that are tightly coupled together on a single entity, and that's what Kubernetes sees.
So then those nodes are grouped into clusters, and then each is overseen by a master node, and then all those have to be managed somehow. So the cluster is probably managed by a deployment file, probably a YAML file. I know you love YAML files.
Yeah, I do.
So then how can we run our game server specifically on Kubernetes?
Yeah, so Kubernetes by itself, it's not suited for memory stateful workloads like game servers, right? For example, Kubernetes deployment, it's mostly uses for stateful workloads, right? That's problem number one. Problem two is that, as we said in the beginning, right, clients need an IP and port to connect to. So that has to be managed somehow, right? So that was problem number two. Problem number three is the auto-scaling process, right? I mean, Kubernetes has some auto-scaling, but it's mostly suited to, again, stateless workloads, right? So we need to teach Kubernetes how to understand, the initializing state, the standing by state, and the active state we talked about before, right? So we need to build something to teach Kubernetes to understand all those things. How do you do it on Kubernetes? You build something called an operator. Two things is an operator. Custom resource definition. So you tell Kubernetes, hey, my GameServerBuild is 1, 2, 3 things. My game server is 1, 2 things. And you build a controller, which is actually code, right, that understands, get events about this custom resource definition and acts upon them, right? We'll talk about it. And that is Thundernetes, right? Actually, Thundernetes is an open source operator we built, teams from Azure and Xbox, right? We host it on GitHub, and actually it's an operator that basically can do all those things.
Yeah, so essentially Thundernetes teaches Kubernetes specifically how to use our game servers.
Yeah.
So Thundernetes is that solution that we created to run the game servers on Kubernetes. So, but what if I'm working on my game? What does my game server specifically need?
So those are some concepts that we borrowed from MPS, right? That's what I said. We use all this experience to build Thundernetes. So first of all, we have the GameServerBuild. A build is actually a specific version of a game server, right? So, your build 0.1, 0.2, whatever, along with any other configuration. Environment variables, configuration files, certificates, assets to mount from storage, everything, right? The build also has auto-scaling by default. So when you create a build, you specify the standing by, how many standing by servers you want. Also, you specify the maximum. In terms of when you have cluster auto-scaling, right, you never want, your cluster to exceed a certain amount of cost, right?
Yes.
Because it's
so
about
you set
cost.
A max, yeah.
So you set the max. The other thing we want is to require integration with GameServer SDK, right, which is open source SDK that serves a couple of purposes, right? First of all, game servers that use GSDK heartbeat to Thundernetes. And with the heartbeat, right, basically, they tell, hey, I'm alive, right? If they don't heartbeat, Thundernetes can detect it and take appropriate action. And then, most important one, status notification. So the game server can use the GSDK to tell to Thundernetes, hey, I'm initializing, hey, I'm standing by. And Thundernetes can use the GSDK to tell to the game server, hey, you're active, you're gonna have some players rolling in, do what's necessary, right? And last but not least, it's very straightforward to integrate. You just need to implement two methods.
Okay, you say two methods, but what if I'm using C#, C++, or Java, or Go, or Unity, or Unreal?
Yeah, that's the good thing about GSDK, right? It's not something we invented now. This has been used from Azure PlayFab multiplayer servers for years, right? So that's why we have open source libraries in all these programming environments you mentioned. It has been battle tested and works great. Amy, you want to tell us a bit about game server lifecycle?
Yeah, so in game server lifecycle, for example, we've created a build with 2 standing by and 4 max. So max means that we will never go above 4, but we always need 2 standing by, which we talked about for the pre-warming. So 1 game server is allocated. A new standing by is created since we needed 2.
And we're less than 4.
Yep, still less than 4. Another game server is allocated. A new standing by is created since we needed 2.
Yeah, still less than equal on 4.
Another game server is allocated. No more standing by are created because remember, standing by plus active equals the max, and our max is 4.
Exactly, we cannot satisfy the requirement of 2, right? Because we have already 4.
So when the game session ends, active is gone, and a new standing by is created since we needed 2, but our max is always 4.
And it's important here to mention that what we mentioned again, right? That we cannot transition from active to standing by, right? To terminate the game process and start fresh. We kill the process, right? We exit gracefully, to say it better, and then Thundernetes will create a new game server for us. So let's talk about Thundernetes, a quick overview, right? We mentioned it's an operator, so we have 2 custom resource definition, right? We have the GameServerBuild, which basically we tell it, hey, we want 1 too many game servers, so the controller will react to that and create game servers, and then another controller will create the pods, right? And that exactly is the word of the controller. You tell it the desired state, and the controllers will do everything in their power to make sure that the world state matches the desired state, right? So what is in the Kubernetes literature, actually, this is called reconciliation, right? So that's it. We also have an API service that we can use to allocate via HTTP. This will be used by your matchmaker or lobby service, right? So they can allocate game servers and a lot of more stuff, right? We're building actually Thundernetes in a modular fashion so we can extend on top of it. And last but not least, right, when we educate Kubernetes about our custom resource definition, you can see on the screenshot that you can do kubectl. You can use, the utility that all Kubernetes developers use and get information about your game servers and builds pretty quickly. So Amy, okay, all this is great, but how can we use Thundernetes?
So a prerequisite for running your Thundernetes workflow is you need a Kubernetes cluster with a public IP per node. You can git clone our Thundernetes repo. This is optional if you want to contribute back or
change something.
Fork,
of course.
of course.
Please do.
So the first step essentially would be to install the Thundernetes via a shell script. Then you're going to configure your game server to work with the GSDK, which is the game server SDK, which is just a few methods. You're going to upload your game server onto a container registry, create and apply a YAML file with GameServerBuild details. I know you love YAML.
Yeah. And just a quick note on there that we have a lot of developer tools for MPS that we can use on Thundernetes to validate that your GSDK is working correctly, right? And going into the YAML file, that is the YAML file that Amy will use shortly in the demo. Hopefully it will work. So we have the GameServerBuild, the kind and the name, pretty standard attributes for anything you create on Kubernetes. Then we have the title ID and the build ID. The title ID represents the game, if you want to have more than one game on a single cluster. And the build ID, as we mentioned, represents the specific version of the game. We talked about standing by and maximum.
Yep, I recognize that. 4 is the max. I recognize that. Okay.
And I'm going to go to the bottom, right, where you have the pod specification. So when you create regular Kubernetes objects like deployments, right, you specify your pod, your containers, your ports, certificates, secrets, assets, everything you want to mount, right? You can do the same here. So what you are used exactly on doing on Kubernetes, you can use it like this.
Same.
Most importantly, last but not least, you will want to expose one or more ports of your game server to the internet. Those ports you're going to expose via the map that we have, the ports to expose map on the YAML, right? This is because we said in the beginning, yes, we need to manage the ports. So we need to know what ports you're going to do. Amy, all this good. Demo time.
Should we actually try to see if we can do a live demo? Okay, so on Thundernetes, on our GitHub repo, we have a quick start guide, and we have our installation script, as we talked about before. So prerequisite, I have a Kubernetes cluster up and running on AKS, our Azure Kubernetes service. I've set some my public IP ports to be exposed to the internet, correct? So I'm going to run this install Thundernetes installation script, this YAML file. It's safe to run this script from the internet, right?
Scripts from the internet. We're good, it's safe.
All right. Let's see.
So we see creates namespaces. You can see the custom resource definition, RBAC rules. So we can configure the access on the cluster, the services. No errors, and the deployment controller manager, which actually are controllers, right, to operate on the CRDs.
Okay, so let's now install a game server. We have a fake game server that you can use that's on the quick start as well. So it's also another YAML file, safe to run this one, right?
It's actually an HTTP server, right, because we want to quickly test our Thundernetes installation, right, and HTTP is a nice way to test it. Right?
Okay.
So we can test outside connections.
So let's use kubectl and getgs, which is to get the game server. Let's see if we have anything running. Okay. So we have 2 standing by. They're healthy. I see they have public IP addresses, which we wanted.
And ports.
And they have ports. So now let's see kubectl, get GSB, which is to get our game server build. All right, so I see 2 standing by, but I don't see any that are active. So we need to allocate, so from standing by to active, and that will unblock ready for players, right? So that's saying, hey, now we're ready to take players.
So as Amy types, right? So imagine that your matchmaker or lobby service, right? Players of the same level or expertise will connect, right? So the matchmaker will decide that it is time for a server, right? To get an active server to send these players. So it will allocate, right? Which is this, will get, well, we already assume that we have this IP, right? The actual allocation call will happen now at Amy due. And once this allocation happens, we will hopefully get an IP and port back.
Which I don't see one, so let's make sure. Let's echo back and see if we get an IP. We did. Okay, so we got an IP. So now we need to do the allocation call, right? So this is going to make sure that we have the build ID, and then I see the session ID.
Session ID quickly identifies a game session, right? So when you log, for example, right, you will need to get the session ID from GSDK and basically log with this. So if you want to debug and investigate, you will know which session, the issue happened.
So I got back.
Look, it worked.
Yeah. So I got back a IP address, and I also got back a port, which is what we expected. So now let's try to curl into our.
Yeah. So this goes back to the clients from the matchmaker,
and
right?
And our
and
port
then players
is
can connect to that
10,001.
one. Yes.
Correct. So if I say hello, I'm going to expect it to echo back a response, right? Same if I was playing a game, I want a response back from the server. So fingers crossed.
Fingers crossed. Yay.
Hello, and we got a response back. Okay. But something we talked about before, the standing by and the active.
Yeah, what's the state of the cluster
yeah,
now?
so
Amy,
let's
right?
see. kubectl.
We had 2 standing by and 4 max, right?
Yep. Get GS.
Look,
Okay.
3 game servers.
Okay, so now I see 3. We have an active one, and it created a new standing by.
Yeah, because we requested 2 standing by, so, and the same on the build.
Yep, let's check the game server build. But live demo, let's make sure Amy can spell.
Yeah.
Yep.
2 out of
And
2 and
standing by.
1. Perfect.
All right.
Good.
Pretty.
Thank you, Amy, for the
Yes,
great demo.
Thank you to the gods and
thanks to the
goddesses
goddesses.
of the demo.
So, with the introduction of Thundernetes, right, Azure and Xbox have 2 offerings for game servers, right? Each one of them is actually tailored for specific needs. MPS is more like a software as a service. Thundernetes is more like a platform as a service, right? So we understand that there are game studios and even games that have different needs. So that's why we have these 2 offerings. For example, you want to run your servers on MPS and have Azure PlayFab manage them 100%, use MPS. You want to manage your own Kubernetes clusters and have cloud-native applications like Prometheus to debug and analyze them, you can use Thundernetes, right? You create a great game that runs on Kubernetes with Thundernetes, right? And at the point in time, it's widely successful, and you want to take people. You want to
work
take
on
people,
version 2.
Yeah, to work on the sequel, right? So you don't want to spend time to manage the cluster. You can take the game as is from Thundernetes and put it on MPS, right? So you can have Azure PlayFab manage it for you.
Because of the GSDK, the game
exactly,
SDK.
because
that's great.
That's why both offerings, right, use the same underlying technology to talk to the control plane, MPS and Thundernetes, the GSDK, right? So, and of course vice versa, right? Thundernetes to MPS and MPS to Thundernetes.
Fabulous.
Wow.
So,
next steps.
Yeah, we would love for you to try Thundernetes with your game. You can take a look at our open source project on our public repo.
We just released 0.3.
Yes,
Go check it out.
on github.com/playfab/Thundernetes.
Yeah, you can give us feedback. You can try the project, everything.
Yeah, contribute, and then keep the conversation going and join us on our Microsoft Game Discord channel at discord.gg/gamestack.
Yeah, and make sure to check out all the great talks on the same channel.
Bye. Thank you.
Thank you.